Hi everyone, my name is Shweta Sen. In this project, I worked on predicting the electrical energy output of a combined cycle power plant, focusing on applying a complete machine learning workflow using real data. At a high level, the goal is to predict hourly power output based on environmental conditions. The data set contained about 9,568 hourly record from the real power plant, including temperature, pressure, humidity, and exhaust vacuum. Because of this is a real operation data, both accuracy and interpretability matters. Since power output is a continuous value, this is supervised regression problem. I selected features with a clear physical relationship to a power generation. For modeling, I used linear regression as a baseline and considered random forest as a more complex alternative. This allowed me to balance the performance and interpretability. To avoid overfitting, I split the data into training, validation, and test sets. The training set was used to build the model. The validation set was used to compare the approaches, and the test set was held out until the end to measure real world performance. Using the training data, I built a linear regression model in Excel. I then evaluated its performing using RMSE on the validation set. I also review how a random forest model perform on this problem. And while it can achieve strong results, it comes at the cost of complexity and lower interpretability. In this case, linear regression already achieves strong validation performance, and because the project priority understanding the model, it was selected as the final approach. These next slides briefly show how the model was built and evaluated in Excel. The first, you can see how the training data was filtered and labeled. Then the regression setup with selected input and output. Next, the learn coefficient, which show how each feature contribute to prediction. Next, the predicted value. If you will see, there is a predicted value R predicted PE and RMSE calculation for both validation and test dataset. These steps ensure the results are transparent and reproducible. For evaluation, I use root mean squared error because it penalizes large mistakes and is measured in megawatts. The key thing here is consistency. The RMSE value are lower and similar on both validation and test set, which tell us the model generalizes well and it's overfitting. Just as importantly, the coefficient makes sense physically. Higher temperature and humidity reduce output, while higher pressure increase it. That alignment gives confidence in the model. To summarize, this project applies a complete machine learning workflow using real operational data. By comparing models, validation decision properly, and focusing on interpretability, linear regression proved to be a strong and practical solution. Thank you for your time.